What's happening? I know. I don't know. I don't think this is working. I don't know. Here we go again. Thanks, WeVideo. All right. Let's see if it's on the main screen here. If I go here, no, I don't know. Guess we're just gonna go with this and hope for the best. Try to make a video through a video. Here we go. Hey, what's the answer to this crazy question? 3, 2, 1, go. Skunk. Right. It's not math. I could get Lexi Samuelis here to answer this question. It's just, horse skunk equals horse X. X has to equal skunk. All right. Just common sense here. All right. So in that open blank of this worksheet that I gave to you, by the way, I can. Today is I can solve simple logarithm and exponent equations. This will not be on your quiz Thursday. I just feel like it's a good thing to do because you have to know everything you need to know Thursday in order to do this. So it's a good review. Plus, it's simple. It's going to be simple. It should be simple. So what I want you to write in that opening is something from my old notes I've used every single year. Helpful hints for solving equations that are exponential. The first thing has everything to do with the horse skunk X idea. So this is exactly along these lines right there. Sometimes it's common sense. So what's common sense? If I got equal bases in an exponential scenario, if I got b to the x equals b to the y, the only way that could be true is if the exponents were equal. You didn't lose the b's, you didn't drop them. You're just using common sense like the horse skunk X equation thing. It really is true. It's actually called a mathematical property. I forgot to cut that from my old notes. I forgot. It's one of those basic properties of math. Simple word too, and it's just losing. I'm losing it right now. I'm definitely losing it. Anyway, sorry. And then it goes the same for logs. I could get Lexi Samuelis in here and go like if I did this for Lexi Samuelis, you don't have to write this, but if I just put this, and then this, and then she'd say, first of all, what's LO6, Dad? And Lexi, just tell me, what do you think X equals? And she'd be like, all right, we have an L, a 0, and a 6, and then an X. She wouldn't even have to know what log is. I'm just joking around, right? You know that's log, correct? Everyone's like, ooh, that's a 0, that's a 6. Then LOG7. Well, X and 7 are in the same position, so X must equal 7. So really, it's the same thing with logs. If I have log equals log, I could just drop them and say, all right, well, X has to equal 7. That would make it balanced and true. Log 7 equals log 7. True. Okay? So it's the same thing with logs. All right, if you don't have that, then it's these. And this is why I like this section right now. Will get more complicated with solving after break. But I like this because in order to solve a log, change it into exponential. I'll show you something a little different. Whatever I do to one side, say it. There is something crazy you can do with this, and this may be on the AP, like what they ask you to do on the AP thing. I really don't have faith this video is going to work. Right? Because where's my face? And then I thought I hit the right box, but we'll see. Nah, just have another fail again. And then the reverse, if it's in exponential form, change it to a log. All right, and then the last one. If you have several logs, this is really why I like this too, then you can rewrite it as a single log, use your properties, and then convert it to an exponent. So that reverts back to number 2. And actually, I renumbered these. It's not really step 1, 2, 3, 4. It's either going to be 2A or 2B. And then you only run into the third thing if you have a logarithm situation where there's more than one log on one side. And then you'll see it. It'll be common sense after 2 days of dealing with. That's what we did Friday. We just did a quizzes as a review of Thursday, and then they threw another assignment at you that had some logarithm properties and then some review concepts someone else made. Okay, so I had an idea that I wanted to do an I do, you do, make this worksheet, but then leave this blank at the beginning as your note writing possibility. And I could change what kind of happens in 2A and 2B. I'll show you, then I'll show you why what I do works. Right? You don't know what that means yet. I'll just trust me. First ones though, I have to do the spore skunk idea. X. Get equal bases. So always kills me. Second hour killed me here. After doing all the notes, they didn't know how to do the first question in the homework. The first question in the homework deals with the first notes in the homework. So be ready for that. Ready? Stalling. Those that are watching this, if this video does actually produce. Just waiting until everyone writes stuff. Now, you got the thing in front of you. What is the main passive-aggressive word in these directions? Without. Okay? So that implies I need to get equal bases. So number, I think it's 11 in your homework. You got to get equal bases. All right. What do you think 36 and 216 have in common? Meaning this number raised to this power equals either one of them. Not 36, 6. Okay. What's 36? A number. But 36 is what? 6 what? Squared. So you can write it in equivalent forms. This should not be a big deal. That's the equivalent form of 36. Okay, this was first hour. We stood here forever. I asked this question and nobody could even think. What's 216? What do you think? 6 to the what power? Take a wild guess. 4 is too much. Because what's 6 times 30? What's 6 times 30? Just answer that question. 6 times 30, 180. Then what's 6 times 6? What do you think 180 plus 36 is? So 6 to the 4th is too large. 1 more 6 times 36 is what I just did there. That would be, you just invaded my brain. Gosh darn it. You kids. All right. I said 6 to the 4th. I said 3 and then I put a 4 there. But I was talking about 4 as a power. And then that's it. I mean, this is really what we can do here. If I have 6 to this power equals 6 to that, really would have to be true then is this power has to equal that then, as long as these bases are equal. So I drop them. And what am I supposed to do with these exponents over here? Anyone? Multiply, which means distribute. Just caught someone last hour doing their homework after the notes and they didn't distribute. And this is also, I like this, algebra skills, so on and so forth. 6b equals 7, and then b equals 7/6. It's always nice to check your answer, but in a no calculator sense, this would be a pain to check, and you never really have time on a test. So we're just going to trust that answer right now. I will tell you in logarithms, you have to check your answers, but I'm not going to get too big in it because we're not really doing this in depth. The only point of this section is to exercise some rules that we already know. And then that's the point of it. Okay, what do you think about 625 and 1/5? What's the common base? Come on, what's the common base, everyone? What do you think 625 is? Come on, 5 to the what? 5th is too much. What's 5 to the 3rd? What's 5 to the 3rd? 125 and then times one more 5. What do you think? 625. So you got have a little bit. So would it be like when we go after break, are the numbers going to be that large on the test? No, we probably wouldn't. I picked these numbers because these are notes. We'll probably try to keep it right around 144. What's 144? Why did I pick that number? 12 squared. So you try to get a base of 12. We'll keep it in our times tables area. You're expected to know 1 through 12 all your times tables. So a little bit on the large side. What's 5? What's this become? Sorry. 5 to the what? Negative first. Here, see why I'm doing this? We're exercising our exponent rules in these things. That's why I enjoy this section. I think it is helpful for Thursday. All right. And then what am I supposed to do with these powers? Multiply. And then anyone that asks me, wait a minute, where did the 5s go? Skunk, horse, X. If I have 5 to this power equals 5 to that, then this has to equal that. It's a simplification of that rule. Add 12 to -1, and then divide. Another not nice. Did you give me the pen? Was that from Friday? Is that from Friday? We have an illegal student in here that can't sign up for Compass. All right. I put DS there, right? I did email them. You saw the email. You saw me do the email. Right. I don't know what's going on. All right. And then really a pain to check if this is correct. Too tough. And then this is why I put this in this section. Now I have a logarithm. Okay. Well, it's still a no calculator because I watch how easy this is. Now I will tell you this: whatever you do to one side, say it. Do the other. This is what they will show on what to do on each side. This is really difficult for me to explain in words. So this is what I'm going to do to both sides. I'm going to create a base of 2. Don't write this. Just watch. I'm going to create a base of 2 to each side and make each side an exponent. What? Here's why this works, and this is why you'll see this in the future. What's 5 to the log base 5 of x? What's the answer to that, everyone? What's 12 to the log base 12 of x? What's the answer to that, everyone? X. What's e to raise to the ln of x when ln is log base e? What's the answer to that? X. This is a property. More people answered as we went. They remembered. And then I proved this property. It's not about proving anymore. It's about knowing. All right. And then that's why this occurs. When I decide to do this, I don't like this, by the way. I just like changing it to an exponent. When I do this, 2 to the log base 2 of x is just x. And then what do I have on the other side? 2 to the negative third. So this does equal x. Get that out of there. But you know what? The same thing is accomplished when I just change it to an exponent. Base, exponent, answer, or argument. That's why this is all I ever do. I want you to be able to understand keys later when I show keys of other teachers. It's not wrong what they do, nor is it wrong what I do. Anyone that claims what I do is wrong, they're a bum and a charlatan. All right, what's 2 to the negative third? If you get -8, there's the door, or there's the window. We'll set you out in the weeds. 1/8. Negative exponents will not end up being, I have a window out there. Actually, they do a good job, though, getting the weeds out of that little middle area. Kind of nice out there. Anyway. Oh, scanning all around the room and seeing how many drinks we have. Log base e. Is that what ln is? Sorry, I got distracted. And then this is whatever you do to one side, say it. Don't ever write this. But this is what you'd have to do. You have to raise, base e both sides. I don't know. It's weird. Then e log base e of x is just what, everyone? X. Or just change it to a logarithm. Change it to an exponent. E raised to the -1/5 equals x. I would have got that on the other side with that e base thing. All right, now why do I have this one? Because I want to put it in calculator ready form. And notice why this solves. We got x by itself. X is now by itself, so I could just analyze what the answer is on the other side. First of all, what's negative exponent rule mean? Flip. But what do I flip? Do I flip 1/5 or do I flip the whole e with that 1/5 on it? You flip the whole e. It's not flip 1/5. And then what does 1/5 power mean? 5th root is correct. So this is why I've also done this one. Sure, it's solving a real basic thing. The solving's done in one step. It's what you do after that. You got to know. And then multiple choice, this probably would not be the listed answer. This wouldn't be the listed answer. This would. We want to see, do you know how to manipulate a negative exponent and then a fractional exponent? 2 different separate things. So that's why I constructed that question on purpose. I made that one to make sure we had that. And then what does it say? Actually, first hour didn't say anything. I made a mistake. Just round to the thousandth. You know why? That's what AP seems to always do. We got a fumble over here. All right. So the AP exam rounds to the thousandth. So what does that mean? Will we be able to get equal bases? Now watch. What do I do first on this one though? What do I do first on this one? What do you think? -8. And it actually makes me infinitely sad for those that add 2. Oh, I just did that to myself. Sabotage myself. All right, so I add 8. No, wrong. Subtract 8. It's subtract 8, right? Okay, 78 then, right? 78. Okay, and then I get sad people that add 2 right now. You're killing me. Okay, and then this is what we're gonna do. Base, exponent, answer. You know what, though? I'm gonna do something. Don't write this. Don't write this. But just imagine this in the future. You know what they're gonna do? The ones that, whatever you do to one side, say it. What they do is they log base 13 both sides. Because you can, and then that's that other rule. Log base 13 of 13 raised to this power is just that power. That's what this ends up being on this side. Then I'm going to erase the green. I'm going to erase this after this because this is exactly the same as changing a logarithm to an exponent. Sorry, changing an exponent to a logarithm. I knew I said that wrong right when I said this. This is the base. This is the base. This is the answer. Yeah, I almost screwed myself up. This is the exponent by itself. So it's the same thing. I know I should have picked different colors on that. You saw me in order. Do that. That's why I think just change an exponent to a logarithm. It's more direct, more simple. Then I guess what? This is calculator ready form. If you're not allowed to use a calculator, then you leave this. And then you add 2, and then that's the answer. That's the calc ready to type on my calculator and go. And that 2 has nothing to do with the logarithm, so it's got to be separated from it. But then I am going to go to the calculator. I do want to slide. I don't think my camera's being used, but I want to slide over to I'm going to slide my podium so I don't choke myself on my cord here for the headphones that I have. And then it's log. I do want to show you this. Clear log. What was it? 78 divided by, this is from Friday's or Thursday's thing, actually. We did this Thursday, the change of base. Sorry. And then log 13. I can't remember. Close that 78. Okay, that parenthesis. Or alpha window. Okay, let you look at those red things that I pressed there. This button has made the change of base formula obsolete. You get, in these days, to be able to just do this. You kids, you got it so lucky. Back in 15 years ago, the students had to use a slide rule to evaluate logarithms. You guys don't even know what a slide rule is. What's a slide rule? That's a joke for people on the internet that remember the 60s and 70s when they'd use slide rules to evaluate logarithms and trigonometry and all this stuff. I think I never used one. 1.69. Who's he talking to right now? The decimal approximate of that. I think they use slide rules for logarithms too. I'll shut up about slide rules. You know what? This should honestly say no calculator in this section. The only reason I couldn't keep it in there was because I put an LN question. But then I should have kept it in there, and then we could have kept it in calculator ready form. This one is not, not needing a calculator. Maybe I think I have something happen here that's kind of big for a calculation. So this is what I have to do with this. I have a plus in here. All right. So what do I do in order to make this condensed? What's plus turn into? What rule? Multiplication. I didn't probably say that perfectly as a mathematician. You know what I mean. This means condensing to log of a product. Sum of 2 logs becomes log of a product of the answer positions. And now I've literally done what I did in number 3 and number 4 for your homework. Base, exponent, answer. Or in AP, make 4 the base on both sides, and then this cancels, and you're left with 3x times 8. But I'm not doing that, but I am, but I'm not. I want you to know how to change a logarithm to an exponent, because I told you you're doomed if you can't do that. This will be an F triple minus test if you can't change a logarithm to an exponent and vice versa. All right, what's 4 squared? What's 16 squared? Which would be what this ends up being. No, what's 16 times 16? Anyone know? 2. It is 2. It is 2. 256. Who got that? Raise your hand. Okay, eventually there we got that. Good. Now again, if we had a no calculator test, we would make the number smaller. Be within your times tables up to 144 probably. Because I made these notes, and then actually I used a program. I like it because the program I have to toggle. I can hit the spacebar and it keeps regenerating questions till I get answers that I like. I purposely did get some bigger numbers here. Okay, watch this. I'm going to impress you with my simplifying skills. At least 2 goes into both of these. 2 times 12 is 24. I just got to do a little bit of thinking on this. 2 times 128 is 256. Guess what? 2 goes into these again. 6 is easy. This is getting a little bit easier. Okay, 64. And then guess what? 2 goes in there one more time. 64 is 32. Divided by 2, 6 is 3. And then that's actually 10 2/3. So if you went ahead and got a decimal, I was just playing around because we should know how to reduce fractions. So it's fun to go through that sometimes. We know how many problems we had with fractions this year, children. So that's why also going through that is not very bad. That is an approximate or exact answer, 10.6 repeating, whatever. What do we do with minus, everybody? And by the way, look at the other side. There is no logarithm. Keep note of that. This is not, we didn't do any horse, skunk, X math because we can't. That's not a logarithm on the right side. So don't worry about that yet. All right. And then I didn't do the noise. Base, exponent, all of this represents the answer. So get rid of the word log, and this turns into 2 to the 4th equals 6 over x plus 4. Let you sink that in here in a minute. But we do have the questions in front of you. So A, you have to use your rule to get it down to the 3 positions. You got 2 different logs. I don't have 3 positions. I don't have the base exponent answer like simplified. What's 2 to the 4th? We already said this number earlier. 16. And then you crisscross, multiply. Anyone know crisscross? Do you guys know crisscross? How many people know crisscross? Raise your hand. Unfortunately, one of them has passed away. Sad. They wore their pants backwards, right? Do you know this? It's a rap group when they were kids. Oh, no, I thought you knew crisscross. You kids. Jump, jump. Anyone know that song? Jump, jump, jump. And it's 2 kids and they're wearing their pants backwards. They're called crisscross. You guys never heard of that? And again, sorry, sadly, one of them is. Yeah. I don't think for good reasons. They, went down a dark path in their life. All right, it is sad. Maybe, I don't know. I know he passed away. I don't know if it was for nefarious and not good reasons. Let's talk about something else. All right, so negative 20 rappers. My favorite rappers are what wrap Christmas presents. I couldn't care less about rappers. All right, anyway. All right, so I just divided by 2, right? As I was talking about crisscross. And then, okay, then I realized at this point in the notes, I completely forgot a particular type of question. So I had to make up one in the first hour. So humor me and stick this wherever you want. All right? Are you okay over there? Oh, was that a big yawn? Okay. I thought you were like holding your head. Okay, and then I hope you understand why this is different. Look at the previous questions. None of them had a logarithm on the right as well. And then I realized in the examples for home or for notes, I didn't have any example like this. Like, what did I do? Because I had some other ones that I liked. I wanted an ln in there, to remind you what ln is. All these good things to remember. And then I'm actually doing in the notes the more difficult ones with the minus. What's minus become? Division. But then notice what happens on this. This is log base 4. And I'm going to do this the other way that I'll tell you not to write, but you can do what you want. I will do it in that other way first. So I'm going to leave some space here. And you'll see why this occurs. And what's the thing that the AP people do? Actually, most teachers do. And I don't know why. I like the idea of what I'm able to do here. What they would do is make 4 a base on both sides. Whatever you do to one side, say it. This is coming out of my brain. This is what I do to both sides. Very weird. Don't write this though. But notice the left side. 4 log base 4 of this is just, say it, this. And then 4 log base 4 of 7 is just what? 7. We can say that because it's not complicated. But really, isn't it the same thing? Horse times skunk equals horse times X. The only way that could be true is if, oh, I didn't get rid of that, is if skunk equals X. What's he talking about skunks for? Right? I wasn't paying attention at the beginning of the movie. But if it's log of this equals log of that, the only way that's true is if this equals that. It's log of this equals log of that, then the only way that could be true is if this equals that. And then we're going to jump. We're going to crisscross. All right? And then multiply. Or, yeah. Okay, 2x minus 3 is what 7 gets multiplied by. And then x minus 1 gets multiplied by 1, so I don't have to write something for that. Try to keep everything here, so it's kind of tough as I shrink this down here. And then you distribute. You just keep your structure. Math is not hard. You just got to keep your structures, pay attention, apply what you learned the previous day, and then keep moving forward. And then that's why I also like this, because now we're distributing, we're solving, we're subtracting x, we're doing some basic solving stuff. We're adding 21, that equals 20, and then x equals 20/13. Now, a pure mathematician at this point is yelling at me if they're watching this movie. Nobody's watching. I know I'm safe. All right, but anyway, you're supposed to check your answers with logarithms. Just listen to my question. We actually should have said, what's the domain of this equation? What can we get for answers or can't? What can't you take the logarithm of? You can't take the log of, starts with a z, I have no time for this, 0, and you can't take the log of a negative. So when we come back from break, we're going to get really into this. And it's really only going to be as hard mathematically as what I'm doing right here, maybe a little bit extension. But then another thing is you have to check your answers with logs. 20/13 is greater than 1. Isn't 20/13 minus 1 then greater than 1 a positive? Good, you checked. 2 times 20/13 is over a half, or 1.5. So 2 times over 1.5 is over 3. Isn't over 3 minus 3 greater than 1 or 0? I mean, yes. And ignore everything I just said there. That's what we have to worry about after break. So I just wanted to do my mathematician thing here of checking these answers. Going back to number 7, 32/3 is large. That's going to be a positive or good. Negative 29/8 is lower than 4. You'd have a positive on the inside. It would work. All right. Now remember I said that. Here we go. Okay. So now I have this. My previous question kind of leaked into it, but that's all right. What's plus mean? What's the rule? Multiplication. So it's log base 5 of, we got something different now. We have a monomial times a binomial, and then 1. Now here's what happens. Notice this last question that I had to make up. Notice it was log equals log when I was done, right? Right. And then we dropped our logs, right? Then we drop our logs. Now that we dropped our logs, I get people that just drop their logs everywhere. Now I'm just going to keep dropping my logs. So I'm going to drop my logs right here, and then I'm going to say x times x plus 4 equals 1. Is that true or false? And all I have to say is, when you drop your logs early, you make a big mess. Anyone? All right, so let's move on. What you're supposed to do when you're, or if I make this 5 to this side equals 5 to that side, I don't even know how to explain that. What's the right side become? What's the right side become? 5. It's not just 1. All right. So this, I have to go back to changing. Are you guys okay over here? Changing this to an exponent. Changing this to an exponent. Got it? All right. Distribute, and then, of course, subtract. Are you ready for this? Good foilers. Anyone? This is why I also love this. We get to do some algebra now. All right. And now we can, so again, for the purposes of Thursday, this is why we're here. Changing an exponent or a logarithm to an exponent. I should choose different colors. All right, but then we just get to do some more algebra. We get to remind you of stuff that we've done all year long. Hey, we have a final exam. Guess what? You're going to foil on that, and you're going to factor, and you're going to solve. All right. Hey, what multiplies a -5 and factors to be, or what? What multiplies a -5 and adds to be 4? Got the drop in the logs in my head here. All right. So what's the answer? It's 5. Sorry, it's 5 and what? -1. X squared, negative x, 5x, and then -5. And then what does that mean x actually equals? Now this is going to be easy to check. X equals -5. Sorry, I lost my 0 there. So you set this equal to 0 and solve. We're seniors. You've done, even in here, you've done this too many times to be confused on x equals -5 and x equals 1. But now we got a problem. What is log base 5 of -5? Does that work? No. And here's the issue. It works after you use the rule. If I put -5 here, this would be, and I'm pointing over here. You can't see my face or see the screen. If I plug in -5 here, then I get -5 times -1. What's -5 times -1? Okay, 5. That took a while. People are getting their calculator out. Beep boop, beep boop. But before that, what's log base 5 of -5? That doesn't work. Don't you dare say -1, because that's 1/5. So this is called an extraneous solution. Again, you don't have to worry about any of this for Thursday. Your brain's overloaded for Thursday's quiz. Ignore what I just said here. This is something we have to worry about after break. I just love solving because of all the things that it does. You have to know everything about logarithms. You have to know your properties. You have to know sum means multiply. That's really know how to change a log to an exponent. It's all good. And you have to know what is ln, log base what? Not the first time we've had this. I mean, today even, it's log base e. And you know that this is log base e. I'm writing it for your purposes. If you don't have to write ln as log base e, fine, but you probably should, because I changed it to an exponent. This is 9 over -5x. And then this is why I could have got away with this. Is there a log on the right side? Is there a log on the right side? No. Or those people that do that, maybe you want to do this. Make e a base to both sides. And then this cancels. And then this becomes 9 over -5x. And then this is e squared on this side. But when I change this to a logarithm, the same exact thing happens. Base, exponent, answer, or argument. Now that we've been using that word lately, the same thing occurs. So I'm okay. I'm not ripping on them for eing both sides, making e of both. I mean, for this case, I think it's good, especially after the drop the logs thing. When does it disappear? Wait a minute. You said this was no calculator. It's fine. Jump, crisscross, right? Hey, you might look at those wrappers up now. And then -5 e squared of x is what or times x, not of x. That's wrong. All right. And then what do we do next to solve for x? We divide by negative 5e squared. And this is not bad to go through. We used to do a lot of if you're a junior going into calculus. I really feel they're still like they still do like calculator ready format, or not calculator ready. Yeah, calculator ready for that's what this is called. It's been so long that I don't even know what it's called. Just don't touch your calculator. That's why it's no calculator. Leave it in terms of E. But then of course, I'm gonna slide this over here. We could. What was it? 5? Oh, it's right there. 9. So 9 divided by no parentheses, no correct answer. You got two things in the denominator. You got 5, and then remind yourself where E is. It's in two places, but the better place is by ln. So second ln. And then raise it to, oh, I forgot the negative. Thanks, Mo. Hey, Mo, you made the video again. All right, negative 5. The other times I was yelling at you, though. All right, second squared, right? So he's right. I forgot the negative. Negative 0.244. Okay, negative 0.244. Really tough to check those answers. But hey, what's a negative times a negative? What's a negative times a negative? So you'll have a positive in there. So it's checked. That's all you have to do when you have to check the answers to make sure they're not extraneous. Okay? All right, so I don't think this was bad. I also had to teach change of base, didn't I? Had to show you a change of base on number here, how to type that on the calculator to get that decimal. That was another property of ours. Log base 13 of 78. This equals log 78 over log 13. So it's just so many things going on in this that are good. All right, I'll try to attempt to stop this video. Yay, I did.